So I want to start by saying that a lot of people are so used to solving equations, they mess up when it comes to just simplifying. Guys, this is not an equation. This is an expression. There is no equal sign here, right? I mean, they don't tell you to solve. They tell you to simplify. And simplify, if you have nothing but numbers, yeah, go for PEMDAS. Parentheses first, then exponents, then multiplication or division, addition or subtraction at the very end. But right here, you actually have variables. So when they tell you to simplify variable expressions, it's two things. What are they? Starts with a D. Distributive property and combining like terms. So you're going to start by distributing. Now, I know a lot of you don't like circling and drawing arrows. Please do it. It'll help you not make mistakes, right? Positive 2 times 8, that's positive 16. Positive 2 times a minus 5, that's a negative 10 with the C. And then, of course, you bring down the 2C that's out here in the front. And after that, you've already distributed. Now it's combining like terms. Combine the C with the C, right? Now, you're not doing, some people, I've seen people do this. Oh, plus 10C, plus, what are you doing? It's not an equation. This is totally wrong. Do not do that, okay? It's not an equation where you have an equal sign, where what you do to one side, you do to the other side. This is just an expression. So you're going to do this in your head. That's why I say circle or box in or underline 2C minus 10C in your head. If you have 2 and you owe 10, negative 8 of those C values. And then you bring down the plus 16, and that's all you could do. That's it. It's simplified. So there's going to be some ridiculously easy questions like that on the midterm, right? Then you have those equations where, yeah, if you have an equal sign and you do something to one side of it, you have to do it to the other side, right? There's already videos explaining all of this stuff. Now, number 7 is a little different than what I have on the videos from last year on the review. So I want to go over number 7 right here with you guys. So in order to understand how to name the sets of numbers to which each number belongs to, I guess there's different ways of tackling this problem. You could classify the square root of 31 and give it a name and see all the different groups it belongs to. And in order to do that, you have to go back and review your notes from the beginning part of the school, right? So we started naturally learning how to count 1, 2, 3, 4. You grew up a little more, you learned about the number 0, 0, 1, 2, 3, 4. And that 0 is the number that has the biggest hole in it. We call that whole numbers. And then we realize you grew up a little bit more. You realize that there's not just 0, 1, 2, 3, but there's also negative 1, 2, 3. So you have positive numbers and negative numbers. Those are called integers. And then you matured the most. You grew up the most. And you realize that not all numbers are nice, like 2 and like negative 3 or like 0. Sometimes you end up with 1/2. Or sometimes you end up with negative 3/4 or negative 0.75 or 7/9 or any type of fraction or decimal. Fractions or decimals are really just ratios, and the word ratio is inside the word rational. So those are rational numbers, but yet they still make sense. You understand when I say I have half a pizza, who wants some, right? You guys understand half. But those are rational. It makes sense. But when we talk about numbers that are crazy, like pi, because it continues forever, 3.1415, and it continues forever, that's what we call an irrational number, a decimal that's crazy, right? There is no pattern. It continues forever. And the square root of any non-perfect square number is also irrational. So now that we've reviewed all the classification of numbers, we could go back and look at the square root of 31. The square root of 36 would be 6, and that would be a nice, perfect, natural number. But the square root of 31, that's a crazy decimal. So what's the square root of 31? Irrational, right? The square root of 31 is irrational. So could we give it any other name? Like, does it belong to any other group? Yeah, you could say it's real, right? It's definitely a real number. All of these numbers are real. So, but irrational is the most important, and of course it is real as well, because all the numbers that we've talked about are real. How about negative 9? Integer. That's an integer. Okay, that's as specific as possible, but it says name the sets of numbers to which each number belongs. So when it says name the sets, as in name all the groups it belongs to, We definitely want to say integer, but what else does it belong to?
Real. Rational.
Real and rational. So there they are, all three sets that it belongs to. So again, -9, we already know that it's an integer, it's a negative number. But it could also be classified as a ratio, a rational number, because -9, you could make it look like a decimal by putting 0.0, or you could also make it look like a fraction by putting -9 over 1. And all of these numbers are real. So it belongs to these three number sets, right? How about -1.25? What do we classify that as? Rational. So rational and real for 1.25. Why is that? Because it's a decimal, and we know that decimals are really ratios. Ratios are rational numbers. And of course, all these numbers are, again, real. How about the square root of 64? Before classifying, we need to know what the square root of 64 is. What is it?
8.
It is 8, right? So we're really classifying the number 8. And the number 8 is... Okay, guys, so 8 is a natural number. That's as specific as possible. But we know that it's also a whole number. And we know that it's an integer. And we know that it's rational. Could be a fraction, could be a decimal. Just put an 8.0 if you want. And we know it's real. So technically, this natural number 8 fits into all those categories, right? It's just like if somebody said 8 is a real number. Well, yeah, duh, of course it's a real number, right? You want to be as specific as possible, you would say natural. Now, you guys just asked, do we have to state natural or do we have to state real? It depends on the multiple choice. Sometimes they might not put real, and that's fine. And as a matter of fact, I think some test generators, they consider natural and whole to be the same thing. So they might not even include the word natural, right? But you want to state all that it belongs to. So you're going to be looking at your multiple choice options and state all of the ones that it belongs to. Okay, so there's one more that was changed from last year's review videos, number 9. So on last year's review video, it had it as f of x equals x squared minus 4x plus 8. And then they say find f of -1. That's just the notation that means exactly the same thing. Okay, so on the test, it's going to read this. I just wanted to show you what they showed on last year's review video. So you don't have to worry about that. I'm going to explain it right now with the correct language, with what you're going to see on tomorrow's midterm. So when they tell you to evaluate, that simply means what? Plug it in. All right, that's what it means. Plug it in. Plug what in? We're going to be plugging in a -1 into the x values because they tell us that x equals -1. Now, the mistake that I see you guys make when you evaluate, when you plug in, is that you guys don't use parentheses. That's right. So let's start this problem by rewriting x squared minus 4x plus 8, but with parentheses instead of x's. So I want to say x squared minus 4x plus 8. Notice I wrote it without the x's, with parentheses replacing those x's. Now it's safe to plug in the -1 right in there and right over here. So let's plug in a -1 right there and a -1 right there. And now we go to PEMDAS, right? Are there any parentheses? Yeah, but there's nothing to do in there. So we move on to E exponents. We do have exponents. It's right here. -1 is the base to the second power. In other words, -1 times -1, +1 is your answer. Let's rewrite everything. Bring down the -4, the times -1, the +8. So there was nothing to do in the parentheses. We already did the exponents. You then move on to multiplication or division. Do we have multiplication or division? Yeah, right here, right? You have subtraction, multiplication, and addition. Of course, you're going to multiply before adding or subtracting. So the way I would do this, I would call this a -4 times a -1. And that'll make it a +4. And of course, bring down the 1 in the front and the +8 at the end. Now it's all pure addition. From left to right, I will get 13 as my final answer. So that's the only difference between last year's videos and today's review, right? Okay, so if you want to watch the other videos to get you prepared, that's great. But we do have a couple of minutes left on this video, so we might as well use it to continue reviewing since we're here already. Number 12. There's many, many different ways of solving this equation. What would you do? What would you do, guys? You could multiply everything by 2 to get rid of the fraction, right? So if you did want to multiply everything by 2, you would have to put a times 2 on this 3, a times 2 on the fraction to get rid of the 2. Do we multiply this g by 2 and this 1 by 2? No, do not do that, guys. Do not multiply the g by 2 or the 1 by 2. Remember, the parentheses, it's kind of like if they protect these guys, right? Whatever you do to this outside guy, it's like if you did it to the inside guys. Why? Because distributive property is going to happen. So whatever you do to this negative 1/2, it's like if you did it to these guys. So what are we doing to the negative 1/2? We're multiplying by 2. So it's kind of like if you multiply these guys by 2. Do not mess with the inside of the parentheses. But of course, you still do need to multiply the 6 also by 2. So what do we have now? We have a new equation that reads 6 minus 1. Why minus 1? Because the 2's canceled, and we have a minus 1 left over. And we still have the parentheses g plus 1, close parentheses, equals 6 times 2, which is 12. So you see how we got rid of that parentheses? I mean, the fraction. But now we have 6 take away 1, and I see other students make mistakes right here. They say 5, and that's incorrect. Because you're not supposed to subtract. What are you supposed to do next? Multiply, distribute, right? Multiply and distribute mean the same thing. So there's multiplication right here. You need to distribute the multiplication. Now, what are we actually going to multiply by? By negative 1. Please include the sign in front of the 1 because that minus sign belongs to the 1. So when you go negative 1 times g, you're going to get negative 1g. When you go negative 1 times 1, you get negative 1. And then you bring down the rest. You have a 6 that comes down, an equal sign, and a 12. So I've already distributed on the left side of the equal sign. Is there any combining like terms? Yeah, there's a 6 minus 1. Since it's on the same side, you're not going to be doing the opposite of minus 1. You're not going to be doing plus 1 or the opposite of 6 minus 6. You're going to combine this in your head. So what is 6 minus 1? That's 5, right? So we have a 5, and we could say it's positive 5. And we also have a minus 1g right behind it. We have the equal sign. We have the 12. There's my new equation. Let me do it all in black. So it's now a 2-step equation. What do I do next? Let me write it up here to have more space. Yes, we're going to subtract 5 to both sides. Minus 5, minus 5. You're going to have a new equation that reads negative 1g equals 7. Final step. Divide by negative 1. Or you could technically multiply by negative 1 as well. Either way, g is going to equal negative 7. So again, all of these questions are explained on the other videos. The only difference is number 9 was written differently, and also number 7 was different. That's why I explained 7 and 9 on this one. Is there any other ones you guys would like to see either on this front page or the back page? So at your request, you guys want to see number 10. I understand you guys want to see number 10 because it looks a little different. We haven't really solved equations with decimals. It's all the same exact thing. The only difference is that on these, it's a great idea to use calculators, all right? So number 10, you want to simplify each side first. Now, there's nothing to do on the left side, but on the right side, there is distributive property. So when you go negative 9 times positive 5n, that's a negative 45n. When you go negative 9 times negative 8, that is a positive 72. Now, on the left side, you still have the negative 201.6. Now, from there, what do? You need to get n by itself on the right side. So what do we do to get n by itself? Subtract 72. And subtract 72. What you do to one side, do to the other. And this is where the calculators come in. So on the calculator, you want to type in negative 201.6 minus 72. Now, this is why I took a picture of the calculators, because on the Texas Instrument, guys, pay attention, because if you're using the Texas Instrument, if you want to type in negative 201.6, you are not going to use the minus sign. It won't read it as a negative. on the Texas Instrument, the negative sign is down here. Really weird, okay? So this button is a negative sign on the Texas Instrument, okay? So if you're using the Texas Instrument, in order to type in negative 201.6, you have to hit this button, negative 201.6, and then you're going to hit minus, because that's a minus 72, hit equal, it'll give you your answer. Now on the Casio, you don't have to use a negative. You could actually just type in the minus sign and it'll read it as a negative. I think the Casio is a little smarter than the Texas Instrument. A negative is the same thing as a minus. So I would go with the Casios if you have the choice, but if you're stuck with the Texas Instrument, make sure you use this button to represent the negative sign. So on the calculator, negative 201.6 minus 72, we get negative 273.6. And that's the left side. And the right side of the equal sign, we have a negative 45n. So if I want to get rid of that negative 45 in front of the n, what do? Divide by negative 45. And we do to one side, do to the other, divide by negative 45. And again, on the calculator, but if you're dividing by a negative with the Texas Instrument, again, make sure that you use that button for the negative. Okay, over here it doesn't matter. You could use a minus sign for a negative, that's fine. But on the Texas Instrument, use that bottom negative sign to represent the negative. So negative 237.6 divided by negative 45 on a calculator gives me 6.08. So my answer is 6.08 equals n equals 6.08. That's the answer. So again, I want to stop right here, but the videos are there explaining everything else. Okay? So if you need help, click on yesterday's post and watch all those other videos that explain all these other questions.